Find the directional derivative of f as a function of three variables at the point P in the direction of vector PQ, boldface, where Q is this point. Now we know that the directional derivative of f in this direction PQ. So first we need to find the unit vector along PQ. So here is P and Q. Let's work here. The vector PQ is just subtract P from Q. 3 minus 2, 1, 1 minus negative 1, 2, 1 minus 3, negative 2. So this is the direction, but to find the directional derivative we need a unit vector along PQ. So unit vector along PQ is just divide the vector by its magnitude. Okay, the vector is 1, 2, negative 2, and its magnitude is just a square root of sum of squares. 1 square 1 plus 2 square 4 plus negative 2 square 4, and this is 4, 4, 8, 9, square root of 9, which is 3. So we need to divide by 3. So 1 over 3, 1/3, 2/3, and negative 2/3. So this is the unit vector in the direction of PQ. So directional derivative in the direction of U vector of f, we want to find this. This is by definition and with gradient vector. That's the gradient of this function dotted with the unit vector, and eventually we want to evaluate this directional derivative at 2, negative 1, 3. Okay, so let's find the del f. Okay, grad f. Del f is just, it's a function of three variables, so fx, fy, fz, which is partial derivative of f with respect to x. There is no x, so 0. Here is x squared, so 2x y. Partial derivative of f with respect to y. X is a constant. Derivative of y is 1, so just x squared plus we have y here as well, and derivative of y squared is 2yg. 2yg is a constant, comma fg, partial derivative of this function with respect to g. There is no g, so 0 plus y squared, derivative of g is 1. Y is a constant, so it's y squared. Okay, so that's the del f, and we can evaluate at this point if we like. Okay, let's do that. So del f at 2, negative 1, 3 is equal to 2, x is 2, y is negative 1, so 2 times 2, 4 times negative 1, negative 4, x is squared, that's 2 squared 4 plus 2 times yg, 2 times negative 1, negative 2 times 3, negative 6, comma y squared, 3 squared 9. So that is negative 4, negative 2, 9. And from the definition of, from the calculation after definition, we can write the directional derivative as dot of this del f at the given point times the unit vector which we found here. Thus directional derivative in the direction of PQ, which is same as in the direction of the unit vector at this point, is equal to this vector dot with the unit vector, which is 1/3, 2/3, negative 2/3, which is just multiply the corresponding components and find their sum. Negative 4 times 1/3, negative 4/3 plus negative 2 times 2/3, negative 4/3 plus 9 times negative 2/3, 3 goes 9, 3 times negative 2, negative 6. Negative 4/3 plus negative 4/3, so negative 8/3 plus 6 is, we can write 18/3, negative by the way, okay. Then negative 18, negative 8, negative 26/3. Final